Okay, this tutorial is for the Alternative Open Reading Frame module of IMG-ACT, the Annotation Collaboration Toolkit. As we recall, I'm still working on this particular assignment, and I'm at the Alternative Open Reading Frame module. As with all of these things, to this point, we have instructions, and those instructions take you to this link up here. Module instructions, alternative open reading frame, right there. Now I'm just going to dive right in, and I'm going to go do it. I need to get to my gene object identifier page and open this page. This is the page that wouldn't open the first time we did this. I'm going to scroll to the bottom where I see this really cool, awesome map of how genes are organized in the bacterial chromosome of Thiomicrospira crunogena. Alright, here's where we're going to be going, but I'm going to go back again to my sequence-based similarity module to remind ourselves of what we're really doing. If you remember from last week, he went through all of this work to come up with this really cool web logo. Now, what we see in this web logo, my web logo isn't working, but what we saw in this web logo of almost everyone who did this, regardless of the sequences they chose, is this big gap right here. This something is up in the alignment of this, and this is an indication that maybe we should look for an alternative open reading frame in our particular gene. If you didn't see this big gap, it is less likely for you to need to look for that alternative open reading frame. And so how we're going to do that, quickly, I'll go back again to my sequence-based similarity module, and I'm going to count this 1, 2, 3, 4, that's about 14 amino acids. So I'm going to look about 14 amino acids or 52 nucleotides into the gene and see if there's something that that was missed in this annotation. So when I do this, I'm also considering the Shine-Delgarno sequence. That's a separate thing. So I'm going to be looking upstream and downstream. I'm going to pick 21 to go 21 base pairs upstream. That Shine-Delgarno sequence is typically located 5 to 13 nucleotides upstream of the start codon. And I picked 21 so it's divisible by 3, so I stay in the same reading frame. It's not intuitive, but you'll see what we get when we click this guy right here. So we're getting the 6 reading frame output of this piece of DNA of Thiomicrospira crunogena, and here is the actual start codon with the associated methionine, and if you go back 1, 2, 3, 4, 5, 6, 7, 8, 9, we see AGG, TGG, the typical sort of Shine-Delgarno sequence is AGG. This could very well be a legitimate Shine-Delgarno sequence for this gene. It's got the proper spacing, and there's a start codon in the DNA right here. Checking up above again, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oops, I'm sorry. I got on the wrong reading frame. Sorry, guys. Let's start over again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So down here, there doesn't look to be any kind of potential start codon, nor up here is there any kind of potential Shine-Delgarno sequence. This is evidence that against an alternative open reading frame. We don't really have anything else to add. So when I go back up to my module, there are no proposed changes in the reading frame, and viewing the 6 frame viewer, looking for start codons and shine Garno sequences and comparing this to the web logo revealed no changes, no evidence for a change. And we save that. We can go back here to Lab Notebook link, and I would just leave this blank. We can click negative strand because we know this is still on the negative strand. But anyway, I think I'll just save that and say that's the end of that tutorial.